Welcome. Today I'm going to show you how to draw fireworks using the HTML5 Canvas. This is a step-by-step tutorial, so better follow along. First, you'll need to have a browser open. I would recommend using incognito mode. This will force the browser to reload a new page whenever you refresh the page. Open the project folder. In your project folder, create a new text file. Rename the text file to fireworks.html. And if you're asked to change the extension, say yes. If you do not see the extension, simply go to Views and select File Name Extensions. Check it and you'll be able to see it. Next, you're going to have to take that file and open in an IDE. For me, my favorite IDE is Visual Studio Code. You can use whatever you want. Some people use Sublime, some people use Notepad++. Next, you're going to drag that file and put it in your browser as well. At the moment, I'm going to just turn this off. And when you press F12, you'll load the debugger from Chrome or Edge. Depends on which one's your favorite browser. Now, if you select the elements, you can see that there's a HTML head body tag. There's a HTML tag, head, and body tag. Those are automatically generated in the browser, but we'll need to type them out. In your file, type doctype HTML tag, similar to what you see in the debugger. Header or head. In the head, we'll have to add the script for our JavaScript. And style for our CSS. And our body tag for our HTML. When you save this and refresh, you'll see that the new tags that we added are reflected in the debugger. Next, we're going to add a canvas. When you type canvas, this is the HTML canvas that we're going to use to display our items. Usually, we need to add an ID to be able to fetch this canvas afterwards. I'll name it ID viewport. It's good to have a naming convention. If I refresh, you'll see that my canvas is here when I highlight it in the elements. I'll give it a border. Canvas border. One pixel solid blue. If I refresh, it'll show a blue border around my canvas here. Usually, I like to put a divider around around my canvas. This way, it'll allow me to have better control over the size of my canvas. And I'll show you what it looks like by typing div border 1 pixel solid red. Refresh. You see that my div stretches around the entire width of the body. Now I want to be able to have this division to max out my entire page. So I'll type width 100%, height 100%. This will make the width and the height 100% of the parent node, which is the body. But the height definition only works with percentage if you define the height for the parent node. So we're going to go ahead and do that. Well, before that, we'll refresh and see that there's no difference. However, if I type body width 100%, height 100 VH. VH is the viewpoint height, so the height of the entire visible area. If I click refresh, you'll see that my division is bigger now. However, it's cutting out of the page. We can fix that. The reason why is because there's a margin here from the body. All we have to do is just type margin 0 pixels. Oops. And usually we do a padding of 0 pixels as well. When we do this, you can see that the division is the entire page right now. Next, we want to remove the scroll bars here. We can do that by simply typing overflow hidden. If we refresh, the borders are gone now. And we should remove the border as we don't see it anymore. Next, we want to stretch our canvas to match the entire div. Normally you could use CSS to do this, but it gives you less control and the pixels of the canvas will be stretched from whatever this is right now, unless you define it. So we're going to do it using JavaScript. First, we're going to have a resize function. To define a function in JavaScript, you first type function, then the name of your function, open brackets, and we're going to go fetch this viewpoint canvas here. Goes to document dot get element by ID, and our ID is ID viewpoint usually it's preferred to have a null check to see if you got the element or not. Null equals not equal to wCanvas. Then now we're going to resize the canvas. I said canvas.width, which defines the width of the canvas to equal to the canvas dot parent node, which fetches the parent node. In our case here would be the division dot offset width. This would give you the width of the parent node that's displayed on screen. We're going to repeat the same thing for the height. Now we need to call this function whenever we resize the screen. So we'll type Windows dot add event listener resize. Resize is one of the events available for the event listener, and our function handler would be resize, which is referring to the function that we just created. If you refresh, you'll notice that our canvas is still the same size, but if we resize the canvas, our canvas would change into the size of the parent node, which is the division which covers the entire page. Next, we need to call this resize before when we first load. How do we do that? We add another event listener. Add event listener load resize. When we refresh, when it loads, the event listener would hear that and resize our canvas to whatever size we need. The reason why I'm calling it through the event listener is because I cannot call it directly in the script tag here like this. This is because this function would be called before the body of the HTML is actually created. So when we get to the resize function, get element by ID viewpoint would not exist. Now when it loads, we want to do something more than just resizing. So what do? We need to define a function called initialization. And here, we could do everything we need during the initialization, including calling our resize function. And we simply change the resize on the event listener for load to initialization. We can even copy this resize function for, we could also copy the event listener for the Windows resize and put it in our initialization function as well. This way it'll look a lot cleaner. Refresh. And you see that there's practically no difference when I move the resize function. If you look at the element, there's a width and a height defined here. Resize the page, and you see that the height is changing as we move the page. That means our canvas is resizing it dynamically. Alright, now we have our base function set up. We have a function to be called when the page loads and a resize function to correct our canvas size when we resize the page. Right now we want to add some animation to our function. We can create to our canvas. We can create another function called animation. I'll just put it on top of my initialization here. can close this. And in our animation page, we're going to try to find the canvas first. Usually, you just copy and paste the code so that we don't have to retype it. Here, since my animation function is going to be using mainly my canvas function, if I cannot find the canvas, I'm going to type return. This would exit my function right away, so it doesn't continue calling. You can put this animation call into your initialization function. This will call it whenever the page initializes. And right now, we're going to draw some circles. To draw something in HTML, you need to first get the context of the canvas. So we can do that. Var wctx equals to canvas dot get context 2D. If null equals to wctx, return. And to draw our circle, we'll first start a new path. wctx dot begin path. wctx dot arc. This would have this function, arc function would allow us to draw an arc with relative to a specific point. You could type just 100, 100 with a radius of 50, angle 0 to 2 pi. Dot pi. And anti-clockwise or clockwise depends on if you're drawing an arc or a full circle. If you're drawing a full circle, it doesn't matter. If you're drawing an arc, it will show the direction of the arc. We'll just set it to false for now. And to actually have it painted on your canvas, you have to type ctx dot stroke. Stroke. Refresh, and we should have a circle at 100, 100. You can change the width of the line using line width. ctx dot line width equals to 10. And you can also change the color by changing the stroke style. This would take either color definition using RGBA, or just normal names and hexadecimal numbers. So for us, we're just going to use red for now. Nothing fancy. And if we want to fill in that circle, we use the fill function. And similar to the stroke, we could define the color of the fill using the fill style. Refresh, and we should have a circle with a blue center. Okay. Oh, typo. File style. Fill style. You see that right now our line is slightly thinner. That's because it first stroked the line and then fill in the circle. We reverse it, then we'll get the full width of the line, because it will be filling in the circle, then drawing the circle around it. Once we have that, we want to be able to, well, let's see. We want to be able to parameterize the entire thing. So let's have my favorite global definitions here. You want to type a comment in JavaScript, use the double slash. This is for a single line comment. If you want to have multi-line comments, use a slash and a star. And close it off with another slash and a star. We just type program functions. It's good to have the section of your code properly segmented so that you can easily follow up afterwards. Var gglobal equals to an object, and in the object I'm going to first type viewpoint ID. And if I want to use this variable, I'm just going to have to type viewpoint ID. This will make it easier when I want to change the viewpoint ID to something else. I don't have to go through the entire code to change it. I just have to change it to here, and my code would work perfectly with my HTML. For example, if I want to type viewpoint 1, my entire code would break. However, if I make it viewpoint 1 here as well, it'll work again. If I type viewpoint wherever I want to get the canvas element, then I would have to go through the entire code to replace it. This is good practice. Try to keep it in mind. And I want to have 10 circles. Eventually they'll turn into fireworks, so I'll name my variable firework count. Put a comma here. So I'm going to have a for loop to create my circles. For this, I'm going to have for var wi equals to 0, wi less than gglobal dot firework count. wi. And here, I can put this code in. I want to have some variations, so I'm going to just do this for now. 10 times wi. The for loop is a really simple loop that everyone should know. It has three arguments, which is the initialization of your counter, well, it doesn't have to be your counter, the exit criteria, and the part where you increment your counter. A lot of people use this for other stuff. I don't recommend it. Keep it clean by just using your counter initialization, exit criteria, and counter increment. When it first begins, it's going to call this part of the function, and every iteration is going to check for this condition before it exits. And it's going to execute this part of the function regardlessly to increment your counter or whatever you use. If I refresh the page, you can see that I have 10 circles here. Well, sort of. That's because they're all close to each other. I could change it to 50. That should show me a better separation of the circles. Now, we're making fireworks, so we need to make these smart circles. They need to move. We're going to do that by first trying to animate them. And we're going to create a class for them. Function fireworks. In our fireworks class, we have the x, y, and radius definition. This will then return an object called with the members x, y, and radius. We'll need to have somewhere to store our fireworks. So in our global, we're going to say firework array. The square brackets will help you define an array. And we're going to create our fireworks in our initialization phase. So we're going to copy this function here and move it all the way here. And here, we're going to create our array of fireworks. Global dot fireworks array dot push. Use the push function to add a new element to your array. New fireworks. And here I would have my function define something. However, I want to have it defined elsewhere. I want to define the fireworks beforehand. New fireworks. Equal to new firework. And here I'm going to type in an arbitrary number for now. This new item that we created, we can push it into our array. We want them to be randomly separated, so here I'm going to make a variable and say x, and we're going to type math dot random. This will give us a random number from 0 to 1 times the rate. Well, we'll make it a random location on the canvas. So we're going to do this. Get the canvas. Check if it's null. If it's not null, move our for loop inside and create our circles. And we can type canvas dot width. If you remember correctly, the width would be the width of the canvas. And then here to height for the Y. The radius, I want it to be a random radius from, let's say, 10 to 50. So math.random times 50 minus 10 plus 10. This would give us a random number from 10 to 40, and then we add 10. So our radius is going to be a random number from 10 to 50. We're going to put these into our function. Wx, wy, the radius. Now we have our array of circles. We need to draw them. Here we're going to just copy Firework array and put it here. Instead of using Firework count, we're going to use Firework array dot length. And then we're going to grab that element, fireworks, or firework, equal to the global firework array, wi. And we just replace the parameters of our circle, our arc function, with whatever we have in our firework array, or firework. Dot y dot radius. Refresh and we should see random circles. Refresh again and you can see that the location of the circle changes every single time because it's randomly generated. Next, we want those circles to be moving. So how do we do that? We need to add a velocity parameter to our fireworks. So in our firework class, we just add idx for the x velocity, idy for the y velocity. Add two more parameters here. dx, dy, idy. And as we add more parameters to our fireworks constructor, we need to add it when we define it too. So we want to copy this, or no, we'll just retype it every single time. Var wdy dx equals to, we want a random number times a base velocity. So math.random, you remember it gives you a number from 0 to 1. going to subtract 0.5 and multiply the entire equation by 2. This simple equation here would give you a random number from -1 to 1. And we want to times this by a base velocity. So once again, define a global variable for that. Firework base velocity x. We're going to say it's 100. And 100 for y. So g global dot fireworks base velocity x, and we're going to do the same thing for y. And we have to add these two new parameters to our constructor here. Right now, if we refresh, it's still doing nothing because the x and the y we're not implementing anything yet. Now, we're going to implement a for loop to calculate the new location of the circle. We're just going to copy this, and here, as I said, it's copy code as much as you can, and you want to segment it as much as you can too properly. So animation phase, we can call it dynamic calculation, or let's call it simulation phase. As we're doing more than just animation now, we should probably define this as a game loop. Remember, when you rename a function, you have to rename the location that you're calling it from. I'll do this for now. And in your game loop, you calculate the new position of each firework. Copy and paste this. You get the fireworks. Firework.x equals to fireworks.dy or dx, or plus equal to. And fireworks.y plus equals to fireworks.dy. Right now, you remember that this function is only called once, so we want to make it so that it's called again in the next iteration, so that we are able to animate the x and y. There's a built-in function for that in JavaScript. It's called requestAnimationFrame, and you call your game loop again. So next iteration, before it renders the screen, it's going to call this game loop function. Refresh. You see that our circle is drawn over and over each iteration with a jump. This is because we need to clear our canvas every single iteration. Let's do that. Before we animate, you just go wctx dot clear rec. Start from 0, 0. Then the width is the canvas width. And the height is canvas dot height. Refresh, and you should no longer see that. But right now, I'm a simulation expert, so this plus equals fireworks.dy does not work for me. We need to have something that's a little bit more realistic. We need to add the time factor in there. How are we going to do that? We're going to calculate the change in time every single iteration. We call it dt. Let's say it's 0.25 now. And we need to multiply this, the velocity, to get the proper change in distance. If you refresh, the motion is a lot slower. If you refresh, the motion is a lot slower. But we want to make it more accurate. How do we do that? We need to calculate the delta time using the system clock. First, we're going to define a parameter called last iteration time. Set it to 0. This parameter, we're going to initialize it as the current clock. So how do we get the current clock? We type var date equals to new date. Global dot last iteration time equals to date dot get time. And every iteration, we're going to calculate the difference between the current clock and the previous clock. So var dt equals to date dot get time minus global dot last iteration time. And then we need to set the last iteration time to whatever the current time is. So it could be used in the next iteration. Call this time calculation. And if we refresh, there is an error. Let's check. This is a good debugging exercise. To debug, go to source and go to your game loop. It's being called. Press F10 to step through the functions. So date is correct. Delta time is 7915. So our time is properly calculated. But the getTime function returns the time in milliseconds. We need that in seconds for our time to be realistic. So we divide it by 1000. Divide equal by 1000 would divide the variable by the argument, which is 1000, and reassign it back to itself. Remove our breakpoint. See? Much better. Now, we want to have the circles stay within. Now we want to have the circles to stay within the viewpoint area. So, in our dynamics function, or simulation function, we need to add some limits. If wfireworks dot x is greater than w canvas dot width, then w fireworks firework dot dx multiply or equal to 0, to negative 1. Refresh. Whenever something hits the wall, it should bounce back. Well, this wall. Maybe we should just try our luck. Oh, we have a good candidate here. Let's see. Boom. See, it bounces back. We're going to repeat the same thing for the other walls as well. The criteria for this wall is fireworks less than 0. You can have an if statement with multiple conditions by simply implementing the OR operator, which is 2 lines, and your condition needs to be properly bracketed. So if fireworks is less than 0, it would bounce back as well. And we're going to copy this and implement a condition for the y as well. For the y, or the vertical velocity, it would be the height. Refresh. See, everything is currently bouncing back into the center. Next, what we want to do is turn these into fireworks. Fireworks tend to fall. So we need to simulate gravity. To simulate gravity, we just have to look into physics. Gravity is the acceleration of 9.81 on the velocity. So we simply have to type w fireworks dot dy equals plus equals to 9.81 times time wdt, and this would make the balls fall downwards. Look at this one here. Slows down and down again. And that is our gravity. Next, instead of bouncing from the sides, I want to shoot the balls from the center whenever it hits this boundary condition. So how do we do that? We're going to merge these two conditions. Remember, use the OR sign and paste all our conditions in there. This is obsolete. Whenever it touches the boundaries, I want to reposition it to a specific location. So, and that location would be wfireworks dot x equals to 50% of the canvas dot width times 0.5, and the height of the canvas, the vertical position of the canvas would be the bottom. For the canvas, it's positive downwards. So the bottom edge would be wCanvas dot height. And I want to shoot the fireworks upwards. So my firework y velocity dot dy would equals to random number math dot random times the global dot firework base velocity y. Positive is downwards, so we want it to go upwards, so it should be negative. So negative 1.0 times this entire value. And as for the x, we want it to be a random number left and right. We can simply copy this function paste it here, and it should be sufficient. Well, we need to remove the multiplication sign. Refresh. Something's wrong. Good thing to debug. So something's wrong. Whenever it teleports to the center, it seems to be stuck. I'm going to put a big point here. Does it go in? It does. The dy is infinity. Why? Let's follow it and see. Oh, it's because random is a function, not a number. And I forgot the brackets. Refresh. As you see, as it goes to center, it's being teleported back to, as it reaches the edge, it's being teleported back to the center and given a random velocity going upwards and sideways. And it's going to fall down too, due to the gravity effect. Right now, the size of the circles are a little bit big. I'm going to change it to something smaller. We have a random radius from 10 to 50. We'll reduce it to, let's say, 2 to the 10, or 5 to 10. And as easily said, now we have smaller balls. Line width is a little bit ugly. I'm going to change it back to 1 pixel, or whatever that is. Now, we want these fireworks to explode. How do we do that? We're going to have a subarray of fireworks. We call them sparks in our fireworks. As usual, in your firework constructor, this time we're going to add an array called spark. And same as our fireworks, we create a constructor as well. sparks. But in the sparks constructor, we don't need to have another subspark unless you want to. And when we initialize our function, we're going to create a set of sparks that's going to be available for each firework. So in the initializer, we're gonna, well, let's define some parameters first. We're going to have something called a spark count. And base velocity for the spark, so spark base velocity. For the sparks, I'm going to make the velocity same on the X and Y direction. So we'll just name it, so we'll just omit the X and Y. We'll make it 100. In our initializer here, where we're creating the fireworks, we're going to edit the fireworks before we put it in our firework array. It doesn't matter, actually. Not spark array. Sparks. This is our array. We're going to have a for loop for var wj equals to 0, wj less than g global dot spark count plus wj. You do not want to mix up the indexes. It's the best way to get an infinite loop, so I don't recommend it. We're going to type a new variable called variable spark, and we are going to initialize it to the same location of our firework. So wx, wy, the radius is, we'll make it smaller, so 5 for now. Ideally, you'll parameterize this one in the gglobal object on top, but I'm lazy for this one. dy and dx will be the same as the fireworks. And then we're going to insert this into our spark array. Now, we need to draw those sparks. This is our game loop, where our animation is. Copy this, replace wi with wj. Replace this with firework dot sparks dot length. So spark equals to firework dot sparks wj. And here we're going to draw every single spark. We want them to be a different color, so we'll need to copy this definition, put it here, and we'll make our sparks, let's say, white. Well, white is not a good idea. Yellow with cyan outline. Because we're changing the color here, we'll need to change it before we draw the fireworks as well. Copy this and put it here. If we refresh, we should see something. Well, there's an error. WY is not defined. If you see an error here, click on console and click on the link here, and you'll see where is it being. You'll see the line of code that's problematic. For us, it's when we defined the initial spark. I use a capital W instead of the one that I used before, which was small w, small cap. And you can see that it's, oh, that's because cyan plus yellow is green. That's why. Doesn't matter. We'll change it later. Type cyan and it should update it to look cyan. Okay. We'll do this. Now we need to animate those sparks. How are we going to do that? Same as we did with the simulation, with the circle or the firework. These are our governing functions. We're just going to copy this for loop definition here. Put it here. Copy this. Take spark. Copy, copy, copy. Paste, paste, paste. This would give us some motion for our sparks. Refresh. You see that the sparks are following our fireworks until it hits the edge condition where the firework are being initialized to a new location. We could change that. So we simply type, well, we simply take this, paste it here, this, and then we copy this definition to our fireworks. Spark dot x equals to w fireworks dot x spark dot y equals w fireworks dot y dx equals to dx dy equals to dy. And now it should follow whenever it hits the edge condition. It teleports with the fireworks, and it moves along with the fireworks because it has a similar dynamics. Now we want the fireworks to go boom. In order to do that, what we need to do is give the fireworks a state. Let's see that. Fireworks. In the constructor, I'm going to type a new parameter called state. And we're going to make it 0. And to change our state, we're going to use the timer as a condition. I want it to drop 2 seconds and then explode. So from its highest point in the arc here, drop 2 seconds and then go boom. So we're going to put another parameter called timer. Initialize it to 0. And we're going to add a parameter called boom time. And this will be 2 seconds. Oops, there's an error here. We need to initialize this when we reset the fireworks. So right here, dot state equals to 0. Dot timer equals to 0. And before we hit that condition, we're going to have to check if it's falling. When it's falling, the dy of our firework is positive. So we could check if wfireworks dot dy is greater than 0. If it is, then wfireworks dot timer plus equals to the change in time, wdt. Then we check if this timer is greater than 2 seconds. wfireworks dot timer is greater than gglobal dot boom time. We check if the state is the new state that we want to. Well, we want to change the firework state to equals to 1. But we want to check the change in state. So we type if wfirework dot state, if in this iteration it equals to 0, then I'm going to change it to 1. If it equals to 1, then I'm going to do nothing. At this state, I want to go through every single spark and give it a random velocity. Copy this one. Copy this for loop, put it in this state, straighten out my code. I don't need to change the spark x and y because it's following. Well, I can set it to what that it would not matter at all, but for the x velocity, I want to give it a random velocity times our base velocity. So if you remember, to have a number from -1 to 1, we type 2 times math.random bracket minus 0.5 and open bracket times this. This would give us a random number from -1 to 1. I want this times gglobal dot spark base velocity. The rest of the function, the firework.dy, is not necessary. We want to have the same thing on the y direction as well. If you do this, we can refresh. We check for something that, well, dropping for 2 seconds, and boom, something new. This one starts dropping 2 seconds, and boom. Now it looks kind of weird that the blue circle is still falling. So we're going to remove that. How do we do that? In our animation function. We had a state function before, so when it's 0, it's going from the bottom to the top, and when the state function is 2, it's exploding. So we just have to check if the firework is in state 0 or state 1. So if wFireworks dot state equals to 0, then we draw this. Copy the colors as well. Else, it would draw the sparks. Let's fix the spacing of our code. Oops. Go back to our function. Else, it'll draw the sparks. So if the fireworks state is 0, then it'll draw the core, which is the dark blue section. Else, it'll draw the sparks, which is the cyan. This is what it looks like. So it goes up. We're focusing on this one then. It goes down for 2 seconds and explodes. Now the sparks are traveling a little bit too far away. I don't want that. I want it like to die out after, let's say, 3 seconds. I'm going to say spark die time. Spark die time. I want it to be 3 seconds. How are we going to use that? We're going to change the state of the firework. So back to our game loop. Here, we check if the state is 0, then we change it to 1 and do this. We could add a new function saying that if wFireworks dot timer is greater than gglobal dot boom time, plus gglobal dot spark time, spark die time. Keep in mind that we want it to first go boom, then add 3 seconds. So this timer that starts when it starts falling down needs to be the sum of the two. And here we're going to change the state of the fireworks. State equals to 2. And here, the part where we reset this, we could change it, add the condition here as well. We could make it its own if statement and say if wfireworks dot state equals 2, then we reset our firework, and we can add the firework state equals to 2 here as well. So what happens is when the firework hits the edge of the canvas, the firework state would be equal to 2. If the spark time, if the spark is, when it's time for the sparks to die, the firework state will equal to 2 as well. And when the firework state equals to 2, it will reset the firework. Let's see what it looks like. We're going to look into this one. Falls down, 2 seconds, boom, 3 seconds, the sparks die out. So we're going to give the spark a little bit more time. Make it 4 seconds. Boom. 4 seconds, the spark dies out. And the main part of our code is working now. Now for the visuals. Fireworks don't work during daytime, so we're going to change it so that the background of the canvas is, let's say, black. In our CSS, under canvas, we're going to say background color black. We no longer need the borderline, so we can erase it. See what it looks like. And those are our fireworks. Turn off our debugger, put to full screen, and enjoy. If you learned anything from my tutorial, remember to subscribe and give me a like to help me with the algorithm. Thank you very much, and hopefully I see you in the next one.